I've been doing this work for over 30 years, and this is a labor of love, this particular new product, which I started shipping February of this year, and we're doing really well on the marketplace. And this is a very new and different idea for a power amplifier. Every part of it's different. It's not big, it's not hot, it's not Class A, it's Class AB. It uses low bias, it uses copper, it uses very new style circuitry that's applied in a very kind of old style way. We're still building everything by hand, and we use all through-hole parts. And you know what through-hole parts are. Through-hole parts are transistors you can actually see. Put your hand on, put them in the board, you solder them, test them. We test all our devices before we put them in the amplifier, and we gain match all the transistors in the amplifier, so they're all exactly the same. You'll notice if you get to stay around these amplifiers long, no matter how long they're on, they don't get very hot. They run them on 42 degrees C. These are all bipolar amplifiers. There's no FETs. There are no digital products in the amplifier. There's no clocks running. Everything's done in the analog domain. It's got a 1.4 kilowatt power supply. It's all linear, so it's got a very, very large toroid inside there, even though it's a pretty small box. I happen to be lucky to have a transformer manufacturer in Bridgeport, Connecticut that makes transformers for me. Sometimes he makes them in 3 or 4 days, which has been really good when we are doing prototypes. In fact, while we were trying to put the first amplifiers together, I was sending my wife here, Petra, to the transformer company every other day with a check, remember, dear? So we spent quite a bit of money on transformers in the beginning, trying to get a set of transformers or a transformer to work in that small a box. I think what it actually took at the end was for me to bring the box to him to let him see the inside, to see how big a transformer we could actually fit in there. And then he worked the form factor out based on the amount of power I wanted. But that being said, this is kind of a radical design in the fact that it has very low gain. The amplifier's got about 30 dBs of gain, and it's got about 5 dBs of feedback, so you've got about 25 dBs of gain, and normally when you're running it. It's a very low circuit design. The front end of the amplifier virtually has no gain, which is very unusual for a solid-state amplifier. Usually there's a lot of gain in the front end. I decided to put gain in a slightly different part. There's no global feedback. As I said, we use all discrete parts. Everything's put together by hand-built, hand-tested. And then we get to the copper, and I'd like to explain a little bit about copper. Copper absorbs heat about 91% faster than aluminum. And that's a big factor for a power transistor, because when you turn on an amplifier and start playing music, power transistors get hot. They're doing all the work. So when the transistor gets hot, it has to dissipate its heat. Usually it's into aluminum. The most important thing about copper is that it takes the heat away really fast. The next most important thing about it is that it retains heat for a relatively long period of time. So it gets to a temperature and it stays there, which is very good for a power transistor. Power transistors tend to want to run at the same temperature all the time. So the thermal mass of the copper and the transistor itself, and the fact that it absorbs the heat so well, they track themselves very well. The difference between the transistor case and the copper heatsink are virtually identical when you measure them. So that's a really important thing. Sometimes when you're using aluminum, there's a 5 to 15% differential between the heat of the device and the heat of the heatsink, which is very important. Low notch distortion, you've heard about that. That's why you want to have a Class A amplifier. And a Class A amplifier, in theory, has really low notch distortion because the amplifier is never switching off. Well, the other way to do it is something I did in here with the driver technology I'm using, and the fact that I can match all the devices in the output stage so that they virtually are the same. So that's another way to do it. So the NPNs and the PNPs have the same gain. So there's very little notch distortion available in an AB amplifier. That's why I don't need very much bias. These amplifiers, when they're on, like right now, are idling about 90 watts from the wall, which is really small. And they'll run about 42 degrees C, which is, if you don't calculate, it's about 107 degrees F.
How much do they draw at full output?
Well, full output at 300 watts, they're probably drawing In the 8 ohms, they're probably drawing about 7 or 8 amps. And it's hard to hold them there because you don't have a steady signal. And
Right.
playing
Yeah,
music,
it's
it's
up
going to
and
be
down.
going up and
Yeah.
down.